Hello, F-sharp. Welcome back. We are continuing our series of introducing F-sharp. Yesterday, what we did is we introduced lists in F-sharp, and we discussed that lists in F-sharp are not the .NET list that you're probably used to working with in C# if you're coming from the C# language. They are linked lists. And F# has a lot of syntax for working with linked lists in a very efficient way. And so we kind of discussed different ways of constructing them. How do we prepend them? How do we actually glue them together? And then some of the basics of list comprehensions. Now what I want to do is show you how to process through lists using recursion. Now, this is a very common thing inside of F# code, and so it's important to get to it early on. How to think about this? And it's so recursion is so powerful, and for me, it was incredibly scary early on. I don't think I got comfortable with recursion until I've been programming. Well, honestly, like the last couple of years. So, well, man, how long have I been like seriously programming now? I think like 11 years, 12 years, something like that. So that kind of gives you like a perspective on like how intimidating recursion has been for me. And now that I look back, I'm like, man, I wish I'd taken the time to work through recursion earlier. And so this lesson is us just kind of having a gentle kind of walk into the realm of recursion, and specifically with F# lists, because you're going to hit it very early on, and it's actually not that bad. So I am going to start with, and like I said, I'm going to start with let my values. And I'm going to have it be 1 to 10. Something very simple. And so this is a very short list comprehension in F#. If I go ahead and run this, my values is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a list of integer, very simple. And let's say we want to get all of the, I'm going to keep it really simple. And like these examples are going to get kind of more complex as we go. Let's say we want to loop through this and just print the odd numbers. The even numbers. We'll do the even numbers. And so I'm going to create a very simple recursive function. So let recursive my printer. And my printer is going to take values. I'm going to say it is a list of int. And also in F#, you might see people also go int list. This is kind of OCaml style for defining types. I actually prefer that, but I believe the style docs say you should be doing it this way. But I really don't care. This is how I do it now because I believe that is in line with the recommendations of Microsoft. But if you see the other style, it's saying the same thing. And so what we need to do now is we want to go through these values. Now, you might want to do something like, I'm trying to think the best way to explain this to you. So like you could say like, hey, for v in my values do, like you would, if v mod 2 equals 0, then print function. And I'm just going to use the interpolated string v. So this is one approach to it. I realize I'm using some facilities of F# that I haven't introduced yet, but this is a for loop. It is just taking this, and for each value in there, it's running whatever this expression is. And all I'm doing is saying like, hey, if V, whatever that value in there is equal, mod 2 of that is equal to 0, it means it's even. And so we should print it out. And so if I go ahead and run this, and we come here, we can see like, okay, it's printing out 2, 4, 6, 8, 10. Okay. So this isn't wrong. This isn't bad or anything like that. But what I'm going to show you now is how to do that using recursion. And, okay, I'm going to change this to my printer. And I'm going to say, let recursive loop. And this is a style that I use a lot. Say that, hey, for values, list, int, and then I'm going to do something in here. And at the end of this, I'm going to say loop values. Okay, so work here. I haven't filled in what is this loop going to be, but the way is a very common thing where you have a function. Inside of that function, you define some recursive loop, which some recursive function, which is essentially your loop logic, and then you call it at the end. And so I'm showing you this because it is likely going to be something you're going to see in F# code out in the wild. So now what I'm going to do is I'm going to reproduce this for loop here, this logic in this recursive loop. So what I'm going to do, and this kind of gets to last time, and I'm just going to scroll up because I still have the logic here. Last time we did this unpacking thing, and the compiler is very angry at us because like, hey, you're not covering all cases. If this is an empty list, this blows up. So now we're going to use a match with statement so that doesn't happen to us. So we're going to go match values with, and we're going to say head, tail. Well, let's say there's nothing in the list. Then if there's nothing in the list, we don't have anything to do. It's just calling unit. But if we have head, tail, now we can do something. And so this was the structural match that we weren't covering for here, because this said like, hey, there has to be something in the list for this to actually work. Now, because we're using this match with statement, we're saying like, hey, in the case that this list that you pass in is empty, so it's matching on this structure, don't do anything, right? Like just stop, like you're done. If on the other case, there is an element and some remaining elements in the list, we want to do something. So in this case, I'm going to go print function. And again, I'm going to use that string interpolation head. And so now what it's going to do is like, okay, I'm decomposing the structure of that F# list. I'm taking that head element, I'm printing it, and then I'm going to call loop on the tail. And so I do something with the head of the list, and whatever is remaining, I'm going to call the loop again with whatever the trailing elements are of the F# linked list. And so last time I kind of talked about the fact this is a linked list and kind of the memory layout implications of that. But this is one of the really nice things about linked lists is that it's really easy to like prepend to them, and then iterating through them and passing their tails around is very efficient. And so a linked list is not always as bad as you might think it is if you're coming from other languages. So don't just write them off out of principle. And F# is very good at optimizing them. And so now I have this function. It's my printer. I've defined this recursive logic inside of it, and I call it at the end. And so if I call my printer with these values, I should see the same result. I have to get all this highlighted here, and let's look at it. And I do. I see. Oh, no, it's not the same result. It's all the values. And why? Because I didn't do this check here. If head mod 2 equals 0, then, okay, now we should get the same result. And I'm going to have to zoom out just a little bit here, just to give myself a little bit more breathing room. So when I run that now, I get 2, 4, 6, 8, 10. Sweet. Fantastic. Okay. So we got through that, and you're probably very unimpressed, which is fair. Because like, Matthew, like, this was so much easier than doing this. Why on earth would you want to do that? Fantastic question. Let's say what we wanted to do instead is not print them out. Let's say we wanted to return them. Say like, okay, well, I want you to process through this list and give me all the even values out of it. Okay, well, how would you do that up here with this logic? Because now it's like, okay, well, if we need to get those values out, because we can't just print. We need to return something from this. But for loops in F#, like the result of the for loop has to just be unit, which is like nothing. Like you can just do something, but you're not actually like, you're not going to return a collection from this. So you need to do something like, and you can't mutate things. So what do you do? Like, let mutable accumulator. Oh my gosh, this is bad. Okay. Accumulator equals accumulator. But we want to put that at the beginning. V. This is, oh no. So if you're like, what on earth are you doing, Matthew? But like, this is me declaring a mutable list, and I'm going to iterate through this, and using mutation, I'm going to prepend these values to the list. Yes, you can technically do this, but now you're utilizing mutation. Notice that mutation for me in my color scheme turns this kind of burnt orangish red color. It means like you might be doing something wrong. So yes, technically you could do this. Heck, we'll even run it, and it returns 10.8642. Ugh, but like, ew. So I'm not saying this is bad. I'm just saying there are alternatives. So, and this is actually, and so this is like, let's take a moment here. This isn't too terrible. I don't like it, not because I know that there's an alternative way that does not use mutation that is also very efficient. And this is so simple right now that you think like, oh, Matthew, you're using a little bit of mutation. That's not that big a deal. But imagine that this logic gets much more complex. And now when you look at this, you're having to process through like, okay, what is the state of this as I'm processing through the loop? So this style it's fine in the micro, but as you keep using this style and the complexity and the size of the problem continues to grow, this will start to break down. It will become more difficult to debug, and it will be more difficult to understand like what is going on, because the state of something is mutating constantly as you go through this. Now, I can hear the imperative programmers arguing with me, and I get that. I appreciate that. But this is part of what I love about F#. F# will allow you to do this. It's not going to yell at you. It's not going to scream at you. If you just need to get a job done, and this is the most straightforward way for you to do it, fine. Get the job done, deliver value to the customer. But I want to show you an alternative that I believe is a more F# idiomatic way of doing it, and I believe more robust long-term as the complexity of this grows. Like, again, it will become much more difficult to debug. So I would strongly encourage you away from this style. It has its place. This is probably not it. So let's look at the alternative, because we have to be able to solve this problem. Let's do it without mutation. And the way we do that is with an accumulator. What are you talking about, Matthew? Like, okay, well, let's add another list to this input. And let's say, hey, if head is mod 2, right? What we are going to do now is say like, hey, you know what? We're going to call loop. We're still going to call it with the tail, but our accumulator, we're going to add that to the head of our accumulator. Else, we're going to loop and not add it to the head of our accumulator. So now we have two different ways of kind of recurring on ourselves. We have the values that we are processing. We have the accumulator that we're using to accumulate the values onto. Now when we call loop though, we need to start it with an empty list. So now what's going to happen, we still have our printer function. It still calls this recursive loop. We have the values that we want to process, and we have this like initial state, this initial accumulator. And as we process through this, we're going to loop, we're going to check values, we're going to check its structure, we're going to decompose it, and we are going to prepend to this accumulator list as we process. And this is all immutable at this point. Like the accumulator list, like it's just adding things onto it. So like the pre-existing list is not changing as you're processing through this. You're just prepending new elements and creating a new list. That new list, that head element points to the previous list. And so that's the beauty of linked lists and how they process this data. So now if I say like, hey, my printer, I created it, and now I want to, oh, come back here. Terminal. Cool. I want to call it. I want to call it with my values. What am I going to get out? Oh, I need to bind it to something. Oh, because it's returning something. Like now, let x equal. What am I doing wrong here? Oh, I need to return something. Oh, perfect. Beautiful. Tail. Okay. Oh, okay. This needs to be an else. Great. Love it. Okay. So I'm calling the loop. I have the values. I have the accumulator. It's coming up here. And if I check the structure of values and there's no remaining elements and values, I am going to return that list that I've been prepending elements onto. Otherwise, I'm going to deconstruct it. I'm going to check, hey, does this head element that I'm processing mod 2 is that equal to 0? If so, loop with the tail elements, the remainder of the linked list, but now I'm going to prepend the head to the accumulator. Otherwise, I'm just going to continue processing the tail and I'm not going to put anything on the accumulator. Okay, let's do this. Yes, same result. 108642. So now we have a list of the even values from our list. Now, what I'm wanting you to take away from this is, okay, this is kind of how we deconstruct lists in F#. And this is how we use recursion to process through these recursive data structures. The humble linked list is kind of one of the first recursive data structures that you're going to come across. And the reason I wanted to get this in early is because once you get your head around this, A, recursion will not become as scary, and B, the power of tree and tree-like data structures will become available to you. And I have found that to be incredibly helpful as I have had to develop more challenging algorithms for very specific scenarios. So this is something I'm wanting to make you aware of very early on. Maybe you end up having to write this code as you start. That's totally fine. This is still more succinct, but again, kind of refer back to my point, like this appears benign at the beginning, but I would suggest the complexity addition that this brings with the mutation is going to make your life worse. And this could even be more succinct. I put lots of type annotations in here to make your life easier if you think this is like really loud, but you can technically take almost all of this type stuff out and it would still understand what it is that you're trying to do. So I just removed values. So yeah, once I remove the type annotation, yeah, this gets a little bit more terse, gets a little bit more succinct. So I want you to start to developing a comfort with working with recursion. I don't want you to wait as long as I did because, like I said, it has now become just such a powerful tool in my toolbox. So that's your quick introduction to decomposing lists, processing through lists, and using kind of recursive loops and being able to have some accumulator that you're using to create state as you go along. So something that would be helpful for me is if there are kind of confusing data structures or problems that you're having a tough time translating to F#. Say like, hey, Matthew, there's this thing that I did in C# or Java or some other language, and you're just really puzzled about how to map that to F#. I would love that because that is one that I'm wanting to create a little bit of a Rosetta Stone, I guess, for, hey, this is how you would solve this problem in that language. Okay, here's the F# way of doing that, just to kind of ease that transition for people, because that was one of the big challenges for me is like, oh my gosh, I know how to do this stuff in VBA, but like everything's impossible in F# because nothing can change. And it was really obnoxious. But if I had had more kind of Rosetta Stone moments like, oh, I see how to translate this. This makes more sense. So let me know down in the comments. What are those algorithms? What are those things that you would like to see translated to F#? Well, until next time, thank you so much for hanging out with me and have a wonderful time writing that awesome code. Bye-bye.